Okay, ji. So we are going to start from the quantities. So we have the fundamental quantities. What is quantities? The quantities are the amount which can be
which can be
measured directly or indirectly. Indirectly. Okay.
measured.
So the quantities shown by units, the quantities
The quantities don't measured.
represented by units in
Why?
daily life, by units in our daily life. Okay. So
Okay.
we have some fundamental units. In some books, they have write base units. But in your AQA, they have written fundamental units. And there are 7 fundamental units. 7 units. That is according to SI system. And their quantities and units are, I will make a list that mass unit is kg, kilogram. Length, its unit will be in meter. That will be the next is the time. Its unit will be seconds. Next is the temperature. Its unit will be Kelvin. And next is the current. Its unit will be ampere. Next is the amount of substance. Its unit will be mole. And next one is the intensity of light. And
Yeah,
its
the unit of temperature is also Celsius, right?
yeah, but according to fundamental or base unit, that will be Kelvin, okay? That will be
Okay.
Kelvin. So that is basically coming in MCQ, okay? And MCQ that is coming how many base units of the physics. So there are always 7 units, okay? And in
Yeah.
your course, they are also called fundamental units, okay? Other than these
Mm-hmm.
7 units, those are called derived units, okay? Other than these 7 units. Mostly in physics, we will use only these 5 units, okay? These 5 units. Mostly in whole physics, okay? In your A
Okay.
level, we will using only these 5 units. It's fine?
Yeah,
Okay.
fine.
Yeah, 5 units will be used only in your regularly in A level. Yeah. Now, there are other units, other than these units are called derived units. What is derived units? The units which is the combination of, base units
Of base units, yeah.
is called derived units. That's fine.
Yeah,
Their example in your course is one of the example is force. Force is a quantity. Its unit is, do you know the unit of force?
yeah.
Sorry,
Yes, Newton, right?
Newton. Exactly. Well done. So Newton N is equal to kg meter per second. You know that. It has
Yeah,
come
I know
out
that.
from F is equal to ma. Now this Newton is a derived unit, okay?
Mm-hmm.
The unit of energy is joule. You know that.
Yeah, I know that.
And joule is equal to kg meter square per second square. It's fine.
Get square per second square.
Yeah. Sorry, it's fine.
Yeah, the energy joule is also Newton times this.
Yeah, exactly. That's a new. That's I will do it. That's equal to basically Newton meter. That is, if you use
Yeah.
the formula, it come out to be Newton meter. It come out to be Newton meter, and you can write in kg meter square per second square. Okay.
Okay.
That's another unit which you have to know coming into paper. That is pressure unit, and the pressure unit.
Pascal.
Sorry.
Pascal. Yeah.
Yeah, exactly. So you know that, Pascal.
Yeah.
Okay, just a moment. Who want to enter into the Zoom? I don't know. Anyone, other person is also want to use the Zoom. Have you given? Oh, I don't know who is the Zoom user.
Oh, sorry. What?
Is there any other person who in our group? Any other person?
No, I'm the only one here.
Okay. It's fine. I don't know. Someone is calling in the Zoom class. Okay, let it go. Okay, Pascal. So Pascal is a unit of pressure and it will be equal to kg per meter per second square. Okay, it's fine.
Yeah.
Similarly, you must remember about the power. You know the unit of power?
Yeah. What?
That's good. That's good. The unit of power is watt, and watt is equal to, so watt is equal to kg per meter. That is, I don't know who is calling us, who is coming in, who want to come to the class. Let me to Alian. Can you wait for a minute?
Sure, no problem. Take your
Yeah,
time.
I don't know who is coming into the class. Let me to end it and let me see who is he. Hello, hello, who is there? Hello, hello, hello. Who is Zoom user? I don't know who is she. Yeah, okay, I'm going to.
Maybe there's a misunderstanding or something. He
Yeah,
accidentally
I
put it.
don't I don't know who is disturbing. That's basically disturbing the class. Okay. So okay. Okay, coming to the power is watt is kg per meter per second cube. Okay. So these are some of the units you have to remember. Some of them will be study into the electrical units. Okay, electrical chapters. It's fine now.
Yes, fine.
Okay. Have you noted this?
Yeah, did it?
Okay. Can I erase it?
Sure, no problem.
Okay, so next is the basically we have the precision, precise, and accuracy. Do you know what it means by precision and accuracy?
I have no idea about British.
It's fine, it's fine. Precision. It's precision, okay? So
Okay.
precise, what is the precise? The values are, no, don't write value, the measurement. The measurements which are which
The
are
measurement
which are close to each other.
are close to each other.
Okay, It's called precise measurement. It's called precise measurement. I will,
Because
yeah, I will give you the example, okay? Then you will fully understand it. Because the definition is coming into paper, so that's why I'm writing the definition. What is accuracy? The measurement which are close to actual value is called accuracy. It's fine. It's called
yes,
accuracy.
fine. Don't worry.
So, for example, if we have the target, if this is our target and we want to hit that target, okay? Yeah, Heather, Alian.
Yeah, what is that?
Yeah, for example, this is the target. This center point is a target, and you have the
Yeah.
four shots to hit the target. And you take the four shots, and your four shots are somewhere you will got here, like here. These are your four shots. So I will say
Yeah.
that these four shots are precise because they are close to each other, but these are not accurate. Okay.
Okay.
But when you take four shots again, and your four shots are there, for example, like that. So I will say these four shots are accurate but not precise. But
Yeah, exactly.
not precise because they are not close to each other, but they are close to the target. Okay. So that's why that is accurate but not precise. It's fine.
Yeah.
Okay. So that's why we always looking toward the precise experiments. We always looking toward the precise experiments. Okay. Not accurate experiment. Because the
Mm.
accurate experiments are not possible in any science. Okay, so that's why we are
Yeah.
looking toward the precise. Okay, the next thing is the error. What is error?
Yeah. Like made in measurement.
Yeah, error, or you can call them uncertainty.
Mhm.
Okay, what is error or uncertainty? The small variation, the small variation.
But sir, error
So
and uncertainty are not the same.
sometimes it has the same. Some okay. Let me to write separately. It will be fine. Then you will not be confused. Okay. So
Okay.
let me write separately. In your course, they have write in the same way. But let me to write separately. Error. What is error? As you say, the doubtful, the doubtful measurement. It's fine.
Measurement. Yeah, exactly.
The doubtful measurement in the value. That is known as error. Okay. And there are three types of error. Uh, yeah, three types of error. One is called instrumental error. Do you know some instrumental error?
Yeah, for example, measuring cylinder.
Yeah. Do you know zero error?
Yeah, when the actual value is the in fact zero, but it gives the other reading instead.
Exactly. That zero error is in mostly in vernier caliper and micrometer. So that is the instrumental error. Okay. The next error,
Okay.
which can be possible, that will be the personal error.
Okay.
Do you know personal error?
Yeah,
Parallax.
parallel.
Do you know that error? Parallax error.
Yeah, for example, you have a measuring cylinder and you don't have the correct eye level.
Exactly, exactly. So your eye should be perpendicular to the reading. So to avoid the parallax error, this is a personal error. Okay. If the person is not interesting to take the reading, so he done that error. Okay.
Okay.
And the next one is the that was the random error. This unknown error. You don't know why the experiment is wrong. So that is the unknown error. Okay. Okay.
Yeah.
Uh, I will write a one single points on each error. So how to correct this instrumental error by adding or by subtracting. Okay.
Mm.
With final reading. With final reading. So you can correct the instrumental error. Okay, that's
Mm.
fine. How can you correct the personal error? So by reading information about the experiment. Okay, so you read experiment properly. So then you can eliminate the personal error. That's fine. But how can you remove the random error? By taking,
By
because,
repeating the measurement,
sorry,
by repeating the experiment.
exactly, exactly. By taking the average, that's good. That's good. By taking the average of the value means repeating the experiment. That's very good. So because we don't know about that error, so that's why we have to take the average of that value. That's fine. That's
That's
fine.
fine. Yeah.
Okay. Have you noted that? Yeah.
Yes, I
Have-
did.
Okay. So now we will move toward the uncertainty. Now, what is uncertainty? The small,
Yeah. And it's about the reading.
the small variation, okay,
Yeah, it's more
in the measurement is called uncertainty.
uncertainty.
Okay, and there are two types of uncertainty. One is known as absolute uncertainty. So I will give you the example of absolute uncertainty. For example, this is a person. This is a person, okay? And I want to find the height of that person. Okay?
Mm.
So that may be a possibility that I got some error at the bottom here, some variation here, and maybe some variation here. Consider to be my variation at the top is 0.5 millimeter and my variation at the bottom is 0.5 millimeter. Then how much the total variation I got in the reading? That will be 0 plus minus 0.1, sorry, plus minus 1.0 millimeter. And this is called absolute uncertainty. That's fine.
Yeah, exactly.
Exactly. For example, you know that is the ruler in case of a scale. Your uncertainty is 1.0 millimeter. In case of vernier caliper, do you know vernier caliper?
Yeah, of course, the one that is used to measure the thickness.
Exactly. So our uncertainty can be possible 0.01 millimeter. Okay. Let's take the example. For example, I want to measure the height of the same person which I given at above value and I got its height is, for example, 20 millimeter. So how I'm going to write the single data, the single uncertainty. So I will write 20 millimeter, sorry, 20 millimeter plus minus 0 plus minus 1.0 millimeter. It's fine.
Yeah.
So that will
Yeah.
be my measured value. This is my measured value. And this is my absolute uncertainty. It's fine. Yeah. Now, the second type of uncertainty is percent percentage uncertainty. The second type of uncertainty is percentage uncertainty. Yeah, can you hear me now?
Of course I can, sir.
Yeah. Okay, so what is how to find the percentage uncertainty? It's very easy. Now I am first considering for the single value, okay, single measurement. Now, for example, if I want to find out the percentage uncertainty of this value, so how I am going to find out what I will do? So percentage uncertainty will be equal to absolute uncertainty divided by measured value into
Yeah.
100%. It's fine?
Times 100%.
Yeah. So that will be 1 divided by 20 is into 100%. And how much you will get? What do you think? How much you will get?
Yeah, 50%.
50%. I don't know some 50%. So that's a very large uncertainty. Mostly our uncertainty is not more than uh, 20%. Okay, but that's my example. So that's why maybe something wrong in the example. Okay, it's fine. Have you noted?
Yeah,
Okay,
I did.
okay. So let's move a little bit forward. Now let's take the average uncertainty. Average values uncertainty. How to find the uncertainties of the average values. Now, for example, I have a circle and I want to find out the diameter of that circle by using vernier caliper. Now, so for
Yeah.
example, I got some values of diameter in millimeters. That was 10.09, 10.12, 10.07, 10.08. Okay. Now, these are my values I measured by the vernier caliper and I found diameter. Now I take the mean value of these values. So that will come out to be how much I will get the mean value. For example, consider to be my mean value is 10.09 millimeter. That's fine. It is considered to be. Now, what is the highest value in my diameter? That is 10.12. What is the lowest value in the diameter? That is 10.07. When you subtracted what you got 0.5 millimeter. It's fine.
Yeah.
Now I'm going to find out, now this is my mean value and this is my subtracted from these small variation. Now how to find their uncertainty? So the percentage uncertainty formula is now half value of average divided by mean value into 100%. Now, what is my value? That is 0.5. Now I take the half of this 0.5, I will get 0.25. And now divided by mean value, that is 10.09 and multiply by 100%. So that's, I will get the uncertainty, okay, of mean value. That is a formula we have to use for the uncertainty. And I will get 2.5%. So it means my mean value have a variation of 2.5%. It's fine? Yeah, either. Oh, sorry. Alian. Yeah, it's fine. Alian.
Yes, why?
Have you understand the example?
Yeah, I did.
Okay. So, so because I have the free version of Zoom, so the time is going to be complete. So, 50% time is going to be complete. Can you rejoin again now? Can you rejoin again now?
Okay.
Okay. Thank you very much.